The nature of matter. Atoms. Nearly 2,500 years ago, the Greek philosopher Democritus asked a simple question. If you break a stick of chalk in half, are both parts still chalk? The answer, of course, is yes. What happens if you break it in half again and again? Can you keep breaking it without changing it into something else? Democritus thought that there had to be a limit, and he was right. He called the smallest piece the atom. The atom is the basic unit of matter. The study of chemistry begins with atoms. Atoms are very small. Placed side by side, 100 million atoms would make a row only about as wide as your little finger. Although they are small, atoms are made up of even smaller particles called protons, neutrons, and electrons. Protons and neutrons. Protons and neutrons have about the same mass. However, protons are positively charged particles, plus sign, and neutrons carry no charge at all. Strong forces hold protons and neutrons together to form the nucleus. The nucleus is the center of the atom. Electrons. An electron is a negatively charged particle, minus sign. An electron has only 1,840 the mass of a proton. Electrons are always moving around the nucleus. They are attracted to the positively charged nucleus. But electrons stay outside the nucleus because of the energy of their motion. Atoms have equal numbers of electrons and protons. So, the positive and negative charges balance and atoms have no charge. Key question: what three particles make up atoms? Protons, neutrons, and electrons are the particles that make up atoms. A carbon atom. A carbon atom has 6 protons and 6 electrons, in addition to the neutrons in its nucleus. Like all atoms, it has no charge, since the number of protons and electrons is equal. Elements and isotopes. An element is a pure substance that is made up of only one kind of atom. Each element has a 1 or 2 letter symbol. For example, the symbol for carbon is C, and the symbol for sodium is Na. The number of protons in the atom of an element is the element's atomic number. Carbon's atomic number is 6 because carbon atoms have 6 protons. Carbon atoms also have 6 electrons. Isotopes. Atoms of an element may have different numbers of neutrons. For example, all atoms of carbon have 6 protons, but each atom may have 6, 7, or 8 neutrons. Atoms of the same element that have different numbers of neutrons are isotopes. The total number of protons and neutrons in an atom is the atom's mass number. Isotopes are named using their mass numbers. A carbon atom with 6 neutrons has a mass number of 12 and is called carbon-12. The table below shows the isotopes of carbon. Radioactive isotopes. Some isotopes are radioactive, which means that the nucleus of the atom breaks down at a constant rate over time. When these isotopes break down, they give off energy or particles called radiation. Radiation can be dangerous, but radioactive isotopes have important uses. Radioactive isotopes can help determine the ages of rocks and fossils. Radiation can help find and treat cancer and kill bacteria. Radioactive isotopes can also serve as labels or tracers to follow how substances move in organisms. Key question: how are all of the isotopes of an element similar? Isotopes of an element all have the same number of protons. Carbon isotopes. isotopes of carbon have the same number of protons, but different numbers of neutrons. Isotopes are named by their mass number, which is the total number of protons and neutrons. So, an isotope that has 6 protons and 6 neutrons is called carbon-12. Chemical compounds. Most elements are not found as single atoms. Instead, they are joined with other elements in compounds. A compound is a substance formed by the chemical combination of 2 or more elements in definite amounts. The number of each element in a compound can be shown by chemical formulas. For example, water has 2 atoms of hydrogen and 1 of oxygen. So the chemical formula for water is H2O. The physical and chemical properties of a compound are different from the properties of the elements that make up the compound. For example, hydrogen and oxygen are gases at room temperature, but they can combine explosively to form liquid water. Key question: how do compounds differ from the elements in them? Compounds have chemical and physical properties that are different from the properties of the elements in them. Chemical bonds. The atoms in compounds are held together by chemical bonds. The 2 main kinds of chemical bonds are ionic and covalent bonds. Ionic bonds. An ionic bond is formed when 1 or more electrons are moved or transferred from one atom to another. An atom that loses electrons becomes positively charged. An atom that gains electrons has a negative charge. These positively and negatively charged atoms are known as ions. Oppositely charged atoms, ions, are attracted to each other. Ionic bonding. Table salt is made up of sodium ions and chloride ions. A sodium ion, Na+, forms when a sodium atom loses 1 electron. A chloride ion, Cl-, forms when a chlorine atom gains 1 electron. These oppositely charged ions attract each other and form an ionic bond. Covalent bonds. Sometimes electrons are shared by atoms instead of being moved from one atom to another. What does it mean to share electrons? It means that the electrons travel around the nuclei of both atoms, forming a covalent bond. There are different types of covalent bonds. When atoms share 2 electrons, the bond is a single covalent bond. If atoms share 4 electrons, then the bond is a double bond. Atoms can also share 6 electrons and form a triple bond. The structure that results when atoms are joined together by covalent bonds is called a molecule. The molecule is the smallest unit of most compounds. The bonds in a water molecule are covalent bonds. Each hydrogen atom in a water molecule is joined to the oxygen atom by a single covalent bond. Oxygen can also form double bonds. For example, the oxygen molecules that you breathe are 2 oxygen atoms joined by a double bond. Key question: what are the main kinds of chemical bonds? The main kinds of chemical bonds are ionic bonds and covalent bonds. Covalent bonding. In a water molecule, each hydrogen atom shares 2 electrons with the oxygen atom. So, each hydrogen atom is joined to the oxygen atom by a covalent bond.